The steel cable was about to snap 3,000 tons suspended 113 meters high, an entire ship hanging in the air. The engineers had 40 seconds to act before catastrophe. But wait, how did a ship end up there in the first place? Somewhere in China, a vessel is being lifted to the height of a 30-story building, not by magic, but by something even more impressive, pure engineering. Imagine this challenge you need to make a ship cross a mountain. Yes, you heard that right, a mountain. China's rivers cut through entire mountain ranges with waterfalls over 100 meters tall and violent currents that would destroy any vessel. For centuries, that was considered impossible to navigate. But do you know what happens when you say impossible to a Chinese engineer? He builds the highest bridge in the world, 565 meters above a valley, so high you can see clouds below you. He constructs hydroelectric dams that generate as much energy as 15 nuclear plants. The Baihetan Dam alone has a capacity of 16 million kilowatts. He drills tunnels through mountains once deemed impenetrable, like the Qinling Tunnel, stretching 18 kilometers through solid rock. He paves highways at over 5,000 meters above sea level, where the air is so thin workers need oxygen tanks. And, yes, he makes ships climb mountains. But let's go back to that ship hanging in the air. How do you lift 3,000 tons like that? The obvious answer would be use a giant elevator, but it's not that simple. You're not just lifting the ship, you're also lifting the water it floats in. And that water weighs as much as the ship itself. Nearly 6,000 tons are being raised over 100 meters high. Now comes the million-dollar question, how do you do that without using enough energy to power an entire city? Chinese engineers designed a system so ingenious, it practically lifts itself. How? With a trick discovered by Archimedes over 2,000 years ago. They built a counterweight, but not just any counterweight. It's a perfectly balanced system where the ship essentially floats up and down as if it weighed nothing. Picture a giant seesaw, on one side the ship in a steel bathtub, on the other massive concrete blocks. When the ship rises, the counterweight falls. When it descends, the counterweight rises. But there's a problem. The tower holding everything up is nearly 200 meters tall, taller than most skyscrapers. And you know what happens to giant metal structures under the sun. They expand just a few millimeters, but enough to throw the whole system out of alignment. The solution engineers installed sensors that detect thermal expansion in real time and automatically adjust the ship's position. The system constantly corrects itself. And the most impressive part, this isn't the only one. China has built several of these systems, each more mind-blowing than the last. At the Three Gorges Dam, the ship elevator operates 22 hours a day just for maintenance and has lifted thousands of vessels. But there's an even crazier one, the Gratte-ciel elevator. This one is 199 meters tall and doesn't lift just one ship at a time. It lifts 3 in different stages. It's like a vertical production line for ships, one entering the first stage, another in the middle, and a third exiting the top maximum efficiency. It takes only 10 minutes for a ship to climb 199 meters. But here's what's truly mind-blowing. This is just a fragment of a much bigger picture. While these ship elevators were being built with insane complexity, cables, counterweights, and hydraulic systems on the other side of the country, other engineers were constructing the Baihetan hydroelectric dam. Not just any dam, the second largest in the world, with a capacity of 16 million kilowatts. Built inside a geologically unstable canyon where earthquakes are not exceptions but routine. Imagine building something the size of multiple cities while the ground literally shakes beneath you. And there's more. At the same time, other teams were diverting entire rivers, not small streams, but massive rivers redirected across 2,700 kilometers, cutting through 10 provinces. Why? Because southern China has too much water and the north doesn't have enough. The solution moved millions of liters through underground tunnels crossing mountains, even as the terrain shifts with the seasons. And the wildest part, while all of this was happening, thousands of workers wearing oxygen masks because the air was too thin were constructing the Qinghai-Tibet Railway across permanently frozen ground at altitudes where breathing is nearly impossible. They laid tracks over permafrost, the kind of soil that melts and freezes, capable of destroying any structure. And yet, they made it work. All of this happened simultaneously, separate projects, different teams, unique challenges, yet all executed at once as if it were the most normal thing in the world. So back to that steel cable about to snap. In reality, there was never any danger. The entire system has triple redundancy. If one cable fails, 12 others hold. If the power goes out to mechanical brakes, lock everything instantly. The ship can remain suspended in midair for days if needed. But the truly frightening part isn't what they've already built. It's what they're planning to build next. And in the next video, you'll see the most insane project of all, one so ambitious that when the first engineers heard the proposal, half thought it was a joke. If you found this impressive, leave a like and subscribe. You won't want to miss what's coming next.